Let's start off with the schematic of the variable power supply. Here's an LM317, a couple of resistors, and I always put an output bypass cap to remove noise. All of this part of the circuit is standard, comes right out of the LM317 spec sheet. Excuse me. What's different is the addition of Q1, MJ2955 or similar PNP transistor, and what I call RB. It's a 10 ohm resistor. In the case of this, I'm going to put 19 volts into it from a laptop power supply. Got a bunch of them. They work fine for this. And that's our basic circuit. What you're supposed to do is it will adjust the voltage output normally through the 5K resistor. But when the current kicks up, most of it will be bypassed through the MJ2955. Let's look at our current and voltages this time. Say I've adjusted my power supply for 10 volts out and I'm drawing 50 milliamps. All of the current for the LM317 needs to pass through RB, the 10 ohm resistor, but 10 ohms at 50 milliamps gives me a half a volt drop across the resistor from 19.7 to 19.2 volts. Because it's connected across the base emitter junction, at this point, it's not enough to turn on the transistor. This is just for argument's sake. I know there's people out here going to say, well, I built it and it didn't work that way. I guarantee you, it may not exactly work with these values because components vary. I know what this particular transistor does. I own it. I measured the HFE. Just to let you know, it may be slightly different. So this is theory, not a finished product. So again, we've got about a half a volt drop across RB, not enough to turn on the MJ2955. So the 50 milliamps is being entirely supplied by the LM317. Now I have significantly upped the current in the circuit. I've left it adjusted for 10 volts output, but now I'm drawing 1000 milliamps or 1 amp through from the power supply. The 10 ohm resistor will not carry most of the current. You will quickly build up to from 19.7 to 19 volts. This is substantially switched on the MJ2955. IC in this case is 950 milliamps, and only about 50 milliamps is going through the LM317. Most of the RB current is actually going through the base collector junction of the transistor and also bypasses the LM317. That's all there is to this. Now you can adjust and alter RB. Say you don't want the Q1 bypass transistor to cut on until you hit, I don't know, 100 milliamps, then change this to a 5 ohm. Maybe you don't want it starting kicking in until 200 milliamps. Maybe you'll change it to a 2.5 or something. It's up to you. That's all there is to the circuit. As you will see in the following video, I can still adjust the voltage, and you will see this thing in actual working circuit. The LM317 will stay cool. This will get warm, and the load, which turned out to be a 12 ohm resistor, will get hot. So, thanks for listening. Enjoy the rest of the video. Alright, here's my LM317 adjustable power supply, and here is the PNP pass transistor, and this meter is actually about 12 volts. This is a load resistor. While it says 10 ohms, it's actually 12.2. Nonetheless, I am pumping continuously 1 amp, as shown by the meter here, is being pumped through the system. The heat sink on the LM317, cool, but the current is being shunted through the large TO3 PNP transistor, and it's getting warm. The load is getting outright hot. And so that's just a demonstration when you connect, taking a PNP transistor and a single resistor, I can really up the current capabilities of this circuit, and I'll explain how that's set up based on the circuit diagram that follows.